VLAN Layer 3 configuration, router on a stick. As you can tell from the graphic, we're just going to dive right into this configuration. Now, before we get started, first off, router on a stick, funny name. I know, right? Like a corn dog. And you will find a lot of network people will mock this configuration saying, oh, what are you going to use that for? I am telling you, you will use this thing all the time. Get some miles on you in the network world, and you will do plenty of router on a stick configurations. Here's the concepts, is essentially you're using an external router to route between VLANs. We saw in a previous nugget in this series with the layer 2 VLAN configuration. Let's just say this guy's in VLAN 10. We're going to kind of build this scenario as we go. This guy's in VLAN 20. That's awesome. They're completely separated from each other. However, if they want to reach each other, they can't. So the idea of a router on a stick is that this guy will come in to a router. Let's just say he crosses that trunk link, comes into the router on VLAN 20, and this router flips him around and puts him out on VLAN 10 to communicate this way and reach the host. So the router on a stick concept makes a lot of sense when you see that traffic flow. Now, how does it do that? How does it handle? Actually, hang on, let me just take off my little trail here so I don't have to redraw everything. Well, the way it does it is by assigning this router a sub-interface in each VLAN that you want it to route for. So let's make this scenario a little bit more meaty, right? We'll say VLAN 10 is actually 10.1.10.0/24, right? Class C subnet. VLAN 20 is 10.1.20.0/24. We know that a VLAN equals a subnet, right? So these are completely different networks. And so what we would do is assign this router two sub-interfaces. We'd have a sub-interface that responds for VLAN 10 and would have the IP address 10.1.10. Let's just go with .1, right? Then that would be the default gate. Let's say this is the .50 computer, so 10.1.10.50. He uses the default gateway of 10.1, and then over here we would have a sub-interface for VLAN 20, which would be 10.1.20.1. This guy's, we'll just say .50 again, 10.1.20.50, and his default gateway would point to the .1 there, and it would respond. So now keep in mind, I know I'm talking fast, I'm going through a lot of concepts. What kind of port does this have to be if it's going to feed both VLAN 10 and VLAN 20 to that router? Well, it's a trunk port, or if you're in another vendor's world, it would be considered a tagged port that includes those VLAN tags. That's how the router knows which sub-interface will respond to that. They'll have one sub-interface that responds to VLAN 20 tags, one sub-interface that responds to VLAN 10 tags, right? So let me go behind the scenes. I'm going to get GNS3 set up in this kind of configuration. I'll get the client IPs configured and everything, and then we'll come back and take a look at what's there. Well, you know what? As I started doing this, I was like, this would be really valuable for people to see and follow along with. So the only thing I've done so far is I went into the virtual PC simulator for GNS3, and you can see client 1 gave the IP address 10.1.10.50, default gateway right there. Client 2, 10.1.20.50, that's this guy over here, with the default gateway of 20.1. So as of right now, we're broken. I mean, there's no routing. And this is a nice clean config that we're going to start off with. So I'm going to go to switch 1, bring him in the screen. You can see him right there. Let's do a quick show VLAN-switch, which on a real Cisco switch, it's going to be just show VLAN. But we can see here no VLANs whatsoever. So let's go in and do VLAN 10. It does this little VLAN database just because GNS3, they've written a little... that's technical. Written a little script that actually goes into a mode called VLAN database, which VLAN database is a dying mode. Actually, it's a dead mode. Only very old Cisco switches actually use them, and that's with the iOS kicking in and saying, hey, warning, this mode isn't going to be around for much longer, but just ignore that. That's just GNS3 wizardry. So we'll say VLAN 10 is created. I'll now do VLAN 20. And you can see it gives this little warning, but it still says, hey, VLAN 20 is added. So let's go back and do a show VLAN-switch. And I can see both of those are now added. Okay, good. Let's go to switch 1. I'm going to have it show the ports right there so that we're able to see what's connected to what. So I can see that we've got computer 1 right here connected to fast Ethernet 1/2. The router on a stick is connected to fast Ethernet 1/5, and then the two switches are connected on 1/1. So let's minimize this out of here for a moment. First off, I'm going to configure the trunk ports. As a matter of fact, coming back here, you can see that my number one thing is to configure a trunk port. However, I'm going to configure multiple ones in this environment because I've got switches connected to switches. So I'll go to switch 1 and I will do global config mode, interface fast Ethernet 1/5. This is going to be the interface connected over here to the router on a stick. That guy has to be a trunk port. So I'll come down here and do switch port mode trunk. That's it. It's that easy. All the VLANs are now forwarding. You can see it's become a .1Q trunk, or 802.1Q as the full standard is. And we'll also go into interface fast Ethernet 1/1, switch port. I should just hit the up arrow. Switch port mode trunk. That now flips this guy right here over to a trunk port. And then, of course, this one, fast Ethernet 1/2, he needs to join the access LAN. So let's go into fast Ethernet 1/2, and we'll do switch port mode access. That is not going to be a trunk. He's only going to access one VLAN, and it will be switch port access VLAN 10. So this guy is now in VLAN 10, and VLAN 10 and 20, both of them are trunking across both of those circuits. Now let's head over to switch 2 and do the rest of it. Bring switch 2 right over. Red Rover, Red Rover. Remember that when you were a kid? All right, so let's do show VLAN switch here. I just want to make sure there's nothing in this configuration. By the way, I am planning on giving these GNS3 topologies to you. I'll include them in the Nugget Lab files for this this series. So switch 2. Let's go into global config mode. That way you can do it with me. VLAN 10. Create it here. You know, that's funny. That is funny that switch 1 would do all this whining and complaining with this VLAN database mode. Then switch 2, because it's funny, I was thinking, you know, in the previous Nugget, I didn't see all those VLAN database warning messages and all that. Switch 2 is like, hey, no worries. I'll take VLANs all day with no complaining. I'm curious why that is. Okay, let's go back and make sure it's applying. Show VLAN switch. Yep, we've got VLAN 10, VLAN 20. We could name them. That would be a best practice, but we'll just say that's fine for now. Global config mode, we'll go into interface fast Ethernet 1/1. That is our what? Trunk. So that is now a trunk port pointing over to switch 1. It's good. Forwarding both VLANs. And by the way, let's just do a show interface fast Ethernet 1/1 switch port. Such a good command. That actually shows this is a trunk. It is using .1Q. Notice we've got administrative mode and operational mode. That means I've configured it as a trunk and it's operating as a trunk. I know that sounds kind of redundant. However, you can have administrative modes of like dynamic where it tries to negotiate. Oh, such a terrible mode. Never use dynamic ever. So dynamic, and then it will tell you what it actually became when it rolled the dice and actually decided to be an access port or a trunk port. Not good. So I always hard code everything. That's why all these are the same. I can see that it is trunking VLANs 1, 10, and 20. That's the other super valuable information going across there. Also show interface trunk. Nice valuable one to have that will show us in a quick view which interfaces are trunks and which ones are forwarding across. Now we've got to go into fast Ethernet 1/2, switch port mode access, and that guy is going to be in switch port access VLAN 20. Right? Good. So let's do a show VLAN dash switch. I just want to make sure he's showing up there. Sure enough, he is. Now, how can we verify? Well, we did. That's about it. You can't really ping anything at this point because everything's broken. These guys are in different VLANs. Well, actually, let's just go back to the graphic right here. So this guy in VLAN 20 can only reach devices in VLAN 20, of which he is the only one. And same thing with this guy, VLAN 10, can only reach other devices in VLAN 10, which he is the only one. So they are very lonely. Let's add the router on a stick. So bring up GNS3 one more time. I don't even think I've opened this guy yet. I haven't. There we go. One of the cool things about GNS3, the guys who created this thing are so smart. When you right click on it and do a change the host name, well, before it's running, it will actually update the running config to reflect that host name, which is it's like nice touch. Way to go, guys. So router on a stick, I'm going to do a show IP interface brief. Because this guy's literally like out of the box, nothing happening here. I know that fast Ethernet 0/0 is connected to this, so that's the one I'm going to do all my configuration on. We've already got the trunk port configured this way, so all the VLANs are headed over. So what do? We come into that router, interface fast Ethernet 0/0. First thing I'm going to do is no shutdown, and that's it. Actually, I'm not going to put any configuration under that physical interface at all. I'm going to do something called sub-interface configuration. This guy will remain blank. Now, side note on Cisco best practice. Truth be told, Cisco's best security practice says no VLAN 1 anywhere. This is the most unadhered to, if I can use that, or ignored, neglected advice that is given. Cisco essentially says you should not use VLAN 1 anywhere, which is the default VLAN of every single switch. You should disable it because it is a known security vulnerability, because otherwise people just plug in, they're on VLAN 1 and they're in your environment, and VLAN 1 is just so pervasive, it's everywhere, and all these different switches can connect to each other and accidentally bridge on VLAN 1. So VLAN 1, they just say don't use VLAN 1. However, it's so hard to get rid of VLAN 1. Why? Because it's out of the box, the default. So a lot of people just use that as kind of the core network, despite Cisco's best practice recommendation. So, side note aside. Let's get back into the router on a stick. I'm going to go into what's up with that. Duplex mismatch, not full duplex. Interesting. That is actually normal. A lot of times, Cisco, I have seen it, it's ironic. With Cisco devices talking to Cisco devices, they fail auto negotiation all the time. So you actually have to go in. Let's do a show interface fast Ethernet 0/0. You know, isn't it ironic that it's like, oh man, I don't know how to auto negotiate, and CDP steps in. It's like, hey, I totally see a duplex mismatch. The other side is not full duplex. You can see it wrap around there. Sorry, I'm not full duplex, but the other side, switch 1, is full duplex. You would think that someone at Cisco would be like, I'm going to do something about this. I'm going to write a little script behind the scene, a little tickle script or something that goes in there and says, okay, well, I'm going to fix myself. And anyway, right, I said I'd stop the side tangents, right? So when I do this show interface, I can see that sure enough, this guy is negotiate half duplex. That's not good. So I'm going to go into interface fast Ethernet 0, speed 100, duplex full. And let's just hop on over to the switch while we're here. Switch, oh, I'm there. Switch 1. I'm going into config T, interface fast Ethernet 1/5, which is where I can see it's all going down. We'll do speed 100, duplex full. By the way, this does, in a production environment, disrupt things. It will cause the interface to go down and back up, which if you're in if you've got a duplex mismatch, things are going bad anyway, right? So what else could you do? But it will cause an interruption in service for everything if you do that. Okay, so that should resolve our duplex issue. Now, let's go in the rest of the way. I'll do interface fast Ethernet 0/1. Now notice I'll hit the question mark here. It's very cryptic. It's like, hey, this is a dot. So I'm going to put dot question mark, and then it says, okay, what sub interface? It should say sub interface. What sub interface number do you want? Now, 99.999% of the time, you're going to make this sub interface number match the VLAN number. But can I emphasize that's actually not required? You can make it whatever you want, but I would say, good, why would you not do that? So .10 will match for VLAN 10. How does it know? Because I'm going to type in the command encapsulation .1q, not so, .1q, and then what VLAN it belongs to. One more sidebar, just because Cisco still likes throwing stuff like this on exams. ISL was Cisco's original trunking language before 802.1q was good. ISL was like such a major improvement over the industry standard 802.1q like 15 years ago, back when VLANs were first like, oh, what a novel concept, VLANs and all that kind of stuff. And then the industry caught up and made this one so much better, but ISL still lingers on in some older iOS versions, so you will see that, but nobody, and I mean nobody, uses that anymore. So we're going to use .1q. I'm going to do the IP address. Now, this is going back to our diagram right here. Now, we're setting up this interface right here, which we just configured to respond for VLAN 10 with that encapsulation .1210. So now this sub-interface is ready to receive. So I'm going to give it the IP address 10.1.10.1. And we should be able to actually do some testing after this. So 10.1.10.1, 255.255.255.0, bam. We go back, show IP interface brief. I'm not even going to do the other one. I want to test it first. So let's come over here, and I'm going to go over to the virtual PC 1, which is this guy right here on the screen. And I'm going to do, let's just do a, can I just type in IP, show IP? Or can I'm not a virtual IP guru yet. So where can you? There's got to be like a show. Yeah, it's like show, right? Show. Yeah, show IP. Brilliant! Okay, so right here, this guy is 10.1.10.50. 10.1.10.1 is the default gateway, which is the router. Let's test it. Let's do a ping 10.1.10.1. Oh, that's so good. So I'm going to come over here to router on a stick and just verify. Let's do a quick show ARP. And you can see, hey, it learned the MAC address of my virtual PC. It just came to me. I was like, how can I prove that that PC really is pinging him? And sure enough, it's there. I can do a ping back 10.1.10.50. He's there. Life is good. But as of right now, the other guy, show IP. Show IP. So he can't ping anything. 10.1.20.1. He is all by himself. Don't want to be all by myself anymore. So we're coming in here, and I'm going to do encapsulation.1q 20. Yeah. Sometimes the absurdity of myself catches up with me like 10 seconds later. I'm like, did I just do that? Okay, so IP address 10.1.20.1, right? 255.255.255.0. Enter. 80s music lovers beware. Ping 10.1.20.1. Oh, it's good. So we are pinging now from breathe a moment. Look at this. We are actually now in this virtual environment, which can I just bring this up? I mean, this is all it is to build. All it is to build this environment is to go in GNS3. We've got, let me hide these symbols. Connect these guys up. I mean, we're actually doing some pretty amazing stuff. We're taking this guy on VLAN 20, routing him in on a port, tagging it, right? It's now coming across the trunk as a tagged VLAN tag, coming into router on a stick who responds on that .20 VLAN interface. Got it. And actually, in this case, just talks right back. It's not all the way exciting yet. Hang on. We've got to put the pen away. Okay, here we go. I'm going to do ping 10.1.10.50. I'm going all the way. Woohoo! So it's going all the way on the router on a stick, looping all the way to the router on a stick, all the way back. Wait a sec. Hang on. This guy does a trace. There we go. Trace 10.1.10.50. Yeah. We've got this showing the router. We're actually going through that router, then reaching the virtual host over here on 10.1.10.50. Isn't that awesome? So we can come back here to router on a stick, show IP interface brief. I know you're like, Jeremy, you're a freak of nature. But I'm telling you, it's really neat when you start getting the router on a stick configuration working, because there's so much you can do with it. Hang on, let's go back here. I'm going practical on you. You are in a customer environment, right? They want, and by the way, I know we're in a service provider series right now on how to do VLANs and routers on sticks and all that kind of stuff. But you at the service provider will often be advising your customers, I would say at a minimum, and oftentimes configuring your customers. Why? Because a lot of times you'll have, here's the service provider, and you'll have a Metro E connection to a customer who says, I want to have a managed router. I'll just put MR, Mr. Router, coming in here by the service provider. So the service provider will actually come in here and configure that for the customer because they're not comfortable doing it themselves because they're too small to afford an IT person. So you can use that router. This is router, right? As a router on a stick for that customer, to where you've got IP phones in there, you've got computers and servers and all that kind of stuff, and you can actually use this guy to segment the different VLANs. This guy will say VLAN 20, just like we had right here. These guys both in VLAN 10, so that when it comes on to your Metro Ethernet connection, and eventually, maybe one branches off to the internet, maybe one goes off to a managed VoIP server to where you're hosting the voice over IP that actually runs that IP phone, you can then go in and configure that router on a stick, that's what this guy would do, to receive connections and route those connections off across and to the internet, across and to the voice over IP server, and yet completely segment those from the customer. Just one practical use you can use. There are many more. Okay, that's what you have to know. right? That's kind of like the certification exam passing material. Can I go into one more thing? And now let me first off say, if you are at capacity right now, if you're like, okay, hang on, between the 80s singing and your configuration, I've got to go back and do that again. Do that, because what I'm about to show you is kind of one of those like, okay, really? Okay, some of you might see this and be like, not an issue. Other people might just get melted by it. So, you remember I mentioned earlier on in this nugget that Cisco says don't use VLAN 1. But question, what if you had to, yes, we're in a little simu environment, right? What if you had to manage these devices, right? What if here's me, the admin who wants to do administration and manage this. How do I get to these devices to manage them? Do I go into those go to my little computer, and I type in telnet 10.1.10.1 and telnet into that guy and manage him there? Well, yeah, but if you do that, then everybody can manage it, right? Because that means everybody on that VLAN can reach this guy via telnet. First off, why are we using telnet? Because it's a lab. Via SSH, via whatever management method. And that's just not good. You don't want management ports or management capabilities open to the general community. So Cisco's best practice says to create a management VLAN. Which is completely isolated and only accessible from certain PCs or certain areas of the network, which you control and you restrict with a physical door and a physical key that opens that door, right? So it's not going to be VLAN 1. Because that's just terrible security to have. And I shouldn't say that because there's probably a lot of people who are like, I've got administration on VLAN 1. It's terrible security to do that. So I would really suggest moving your management VLAN off into another VLAN. We're going to make it VLAN 99 in this case. So how do you do that? Watch closely. I'm going to go over to, let's go router on a stick first off. Let's create a new subinterface. We'll say interface fast Ethernet 0/0.99 encapsulation .1Q99, right? That'll be what it responds to. And let's just make it IP address 10.1.99.1, right? 255.255.255.0. Description management restricted. Right. This is where we would go beyond this nugget in the series and put access lists on there and restrict who can get to this interface and what port numbers and blah, blah, blah. There's a lot more to it, but this is essentially how you would lay the VLAN security for it. So I've got VLAN 99, who's accessible by, who can get to that right now? Nobody. The only thing that has that right now is that router on a stick. So I'm going to hop on over to switch number, let's go switch number 1. Hang on, I hit my wrong button. There we go. Switch number 1. And I'm going to exit out of here. Let's do VLAN 99. I still don't know why it does this little VLAN database thing. Anyway, it works, right? Now, watch this. I'm going to do a show IP interface brief on this guy. Now, this guy is a phantom. It is a switch without an IP address. Now, you can see I've got this VLAN 1, which is administratively down, but we're going to keep it that way. I'm going to go in and create interface VLAN 99, no shutdown IP address, 10.1 or 10.1.99. Let's just go 10. 255.255.255.0, right? And now I created VLAN 99, right? Show IP interface brief. And because this guy is on a trunk port, show interface trunk, because VLAN 99 is allowed across the trunk port, is actually up and running. Now, here's what I would do. I would actually, in a real environment, light up a port on this switch. I would say, port fast Ethernet 1/10, let's just say, will be an access port in VLAN 99, and I would take a little cable from that port and go, up through the ceiling, through the barrier number 1, over the barrier, right here with the alligator pit with alligators. Chomp, 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 chomp. Don't come in here. Those are poisonous tentacles these alligators have. And then, past the barrier through, the ladder, cross, a giant pit abyss of death, and then right here that cable would run finally to my management workstation where I would sit behind my alligator and ladders and manage this device remotely. So that would actually be assigned to VLAN 99. So my computer could come in here and telnet to 10.1.99.10 and reach this device. I would telnet to 10.1.99. 10.1.9. You see what I'm doing right here? .1, right? So I can reach this device. And of course, this guy doesn't exist yet, so I'm ashamed to make my poisonous alligators go away. But I will, in order to come over here to switch number 2, VLAN 99, create it. And interface VLAN 99, IP address 10.1.99.11. 11 we'll go with 255.255, and you obviously have full documentation of this by the side. This just shows how it works, and there it is. I mean, what I just showed you right there is the core behind configuring a management VLAN, which completely isolates all your management from everything else. Then from there on out, and let me just kind of wrap up that management discussion by saying this: you would start sourcing everything on your devices from that. So for instance, SNMP traffic to monitor this. By the way, that was part of the SPN GN1 series, talking about management with SNMP or SSH or Telnet or other things that need to be TFTP. There we go, TFTP. FTP, HTTP, all of these protocols that we can use to manage our devices, all of them would be sourced, and there's a command, by the way, that you can do this with on the devices. Every one of those protocols, you can say, use the source of interface VLAN 99, so it always starts communicating on that isolated management VLAN instead of sending dangerous management traffic, if somebody were to capture it, across a production network. Good. Now that... I'll just wrap up by saying that was bonus information. You won't see management VLANs and all that kind of stuff on the SPNG N2 exam, but I think super valuable for you to see because you will. You will see that. You will do that eventually in a network environment. So we have seen the configuration of a router on a stick. We've seen the devices configured in separate VLANs able to ping through that router on a stick, even though they are in separate VLANs and reach each other. I hope this has been informative for you, and I'd like to thank you for viewing.